With this question, we have to first fill in the Venn diagram and then use this to work out the probability question at the end. So as always with questions like this, we try and start in the middle, and we've got here that 2 speak French, German and Spanish. 4 speak French and Spanish, but not German. 7 speak German and Spanish. Well, we've already got 2 of them in here, so that means we're going to have 5 in this section here. We've got 8 who don't speak any of the languages. They can go anywhere outside. And all 10 people who speak German speak at least one other language. So we've got 7 here, so that's 3 who speak French and German, but not Spanish. 31 speak French, so we've already got 9 here. So we've got 22 just speaking French. Well, we know with the Germans it said all 10 speak at least one other language, so that's 0 there. And we just need to work out now how many speak Spanish here. So if we add up all the numbers we got, we should get 44, which gives us 6 just speaking Spanish. So that's the first part done. We then had 2 of these people chosen at random. We had to work out the probability they both only speak Spanish. So the first person, there's 6 people who only speak Spanish out of a total of 50 people. The second person, well, from to both speak Spanish, there's 5 Spanish speakers left out of 1 less person, so out of 49, and we have to multiply those to find out the probability we need. Before we do that, we can cancel down our equation, divide both of those by 5, which makes things a bit simpler. So we get 6 over 490. We could simplify it a bit further, but it's fine to leave it like that. So this question is about combinations and permutations. Saying we've got a set of 6 numbers and we need to find as many subsets as possible. So as many sets containing just those elements where no integers share a common factor other than 1. So that means the numbers 2, 4 and 6 can't go in a set together, and the numbers 3 and 6 can't either. So we need to try and organise our thinking here. So let's think the number of sets with just 1 element. Could start with the number 1, with the number 2, and so on. So there's 6 possible sets just with 1 element. So the number of sets with 2 elements, I'm going to get a bit lazy here and stop using those braces. We need to work out all the possibilities. So we could have 1 and 2, or 1 and 3, and so on. So they're all the possible ones with 1 in there. If we've got a 2 in there, we could have 2 and 3. We can't have 2 and 4. We can have 2 and 5. Can't have 2 and 6. We've already got 3 and 1 and 3 and 2. The order doesn't matter for this. We could have 3 and 4. Could have 3 and 5. Can't have 3 and 6. So there's 11 possible subsets with 2 elements. Looking at those with 3 elements, we've got 8 possibilities here. Then we need to look at 4 elements. And we've just got 2 possibilities here. And there's no possible sets with 5 elements, because remember we can't have 2, 4 and 6, any of those in the same set together. So if we add up what we've got here, we've got 27 distinct possibilities.